Hey, starting over because I didn't click the record button. We are going to be adding a third-party library to our app to replace the Fetch built-in API for fetching data with a better one called Axios, which is a third-party library available to us from NPM. So if you go to npmjs.com, this is the repository where all of the third-party node packages live. And the one we're going to be used is called Axios. Right? So this NPM, well, you can search for just about anything and everything that's on here. So as you're looking for various libraries or someone tells you about a JavaScript library, almost assuredly you can find it on here as long as it's a node library. All right. So the one we're going to use is Axios. And it's going to be a library for pulling data off of the web and sending data to an API. So to add something to our crypto tracker from the terminal, from the directory where our project is, because this is going to add something to this project, it's not a global thing. We're saying our crypto tracker project is going to get the Axios library.
Can we do it now?
Mm-hmm.
Okay.
So if we want to add the Axios library to our crypto tracker project, from our crypto tracker directory, we will yarn add Axios, A-X-I-O-S. So this will tell our project that we're going to be adding another library to our project. And you'll see an interface that looks a lot like the progress bar we get when we're writing Create React App. Yarn, the package manager, is going out to the web, finding the Axios library from npm.js, and it's bringing in that library plus all of the libraries that it depends on and adding it to our project so that we may then use it. So Axios may use other libraries, and those libraries may use libraries, and so forth and so on. It brings in all of those libraries and allows us to be able to use the Axios API library. So you see it saved 3 new dependencies. Here's our Axios library. It's been added. Once that library has been added, now we can use it in our code. So to use the Axios library, like importing React from React, we're going to import Axios from the Axios library. And notice I didn't do / because I'm importing from the list of libraries. This is not a file I've written. This is a library that we have that we're importing from. So we're going to import the Axios library from Axios. This now gives us this Axios variable that we can use in our code. What happened? Cannot resolve index.js. Oh, I may have to restart Yarn. I may have to restart Yarn start after doing this.
So do we have to enter that install, the little install message first?
No. Yarn add Axios. Are you in your crypto tracker directory?
I'm working on creating it. Well, I'm in Minesweeper.
Yeah. Yarn add Axios. Anybody else get an error doing yarn add Axios? If so, we'll look at your error later.
Yeah, it just didn't do anything.
Yarn.
Control-C out of
You have to be at a terminal prompt. So either you can stop yarn or you can start a new terminal. So your terminal can only do one thing at a time. So if you have a terminal that's running yarn start, that's the only thing that terminal is going to be able to do until you stop it. So you have a choice. Either you can stop your yarn start by Control-C and doing the command, or you can do like me and have 2 terminal windows open. Whatever your heart desires. Doesn't matter to me. You may have to restart your yarn start after adding Axios. Seems like that was the case for me. So you might just want to stop your yarns and start it over again. Because I'm still waiting for it to restart. Come on, development server. There we go. So you may have to restart your yarn start after doing the yarn add Axios. So in your case, it might be better just to stop your yarn, do yarn add Axios, and then restart yarn start. If that's okay, now we can use the Axios library. So Axios, the variable, gives us various methods we can call, and one of them is get. So get works much like fetch. We can give it the URL we want to fetch. Let's copy all of this, and let's paste it here. It's hard to keep the font size large and this window going. So we will call Axios get and give it the URL we want to fetch. What's nice with Axios is we can then just work with the API data. There's no other work we have to do here. Why am I getting a formatting thing? Axios get. Why is this in red? Let's see if when I save it, it works. So with Axios, yeah, I have some syntax error. So here's my backtick. Does anybody see what's wrong here? I've got a backtick here, and I've got a backtick here. I have some syntax error. Let's get rid of the fetch. We don't need the fetch. Here's our URL. Let's make a variable for the URL. Let's make a variable for the URL and use the URL here. That's weird. I don't know why it didn't work in line. So what's nice with Axios is it can figure out the data as we go, although we got a cannot read property USD of undefined. So the idea here is that we don't have to have that extra boilerplate. Let me see if they'll take their conversation somewhere else. So Axios is going to give us two things: the ability to not have to have that extra boilerplate for having the response JSON bits, and it will allow us to do the other kinds of web requests we want to do. Let's see if we can figure out now why this is failing here. It's telling us cannot read property USD of undefined. So it's telling us this currency quotes is coming back as undefined. So let's log the API data here inside of what comes back from Axios. Right? So this then is like our old last then on our fetch API. We should be able to see what this data is in our console. Let's see if we have some problem with the data. Let's look in the console and see if we can figure it out. Aha. So I forgot that when Axios returns something, it returns now an object where our data that comes back from the API is inside of a thing called data. So Axios returns us a lot more information, so we can get the status, the headers, the request, but the data that comes back from the API is inside of a method called data. So this is really, let's call this response. So response is the object that Axios gives us. Data is what Axios is going to call whatever data comes back from the API. And then for naming purposes, unfortunately, inside of that data is a thing called data. So normally this will be whatever comes back from the API. And then this is then parsing any of that information on the inside. I'll give a short example of doing this with Minesweeper so you all can see what that looks like before we're done. All right. But the nice part's going to be, here in a second, if we have to do something other than gets, we'll see how that works. So this is kind of the first thing, is y'all are probably going to want to use Axios as your library of choice for doing API work, probably from now until the end of the program. And that's what all of the cohort 11 folks have switched to. It's just easier. We show you Fetch because it's built into most browsers now. There was a time where Fetch was not working in Safari, but I think it's working in Safari now. But Axios is going to be easier. So that's the first thing we're going to do. And I'll make sure there's a demo of it for Minesweeper. Question, Chris? Oh, okay. So here's the next thing we're going to have to deal with in Minesweeper. So eventually in your Minesweeper, you're going to want to be able to click and right-click on the individual elements in your Minesweeper grid, right? Whatever HTML structure you use for that. You're going to have some element in there that's representing that square. And you want to be able to click on it and have something happen. But that cell is not going to be the thing that's keeping the state of the entire board of Minesweeper. So the event's going to happen in a component down below, but the state is going to be up above. Okay. So this is going to pose a problem for us. How do we, when we modify that cell, affect the state in a parent component? Right? So you're probably going to have a board component in your app, and that board component is going to have child components like a cell. Maybe you have a row component, I don't know, depends on how you structure it. But at some point you're going to have a board component for the entire board, and you're going to have a cell component representing each cell in that board. So let's talk about how we deal with maintaining and modifying state when events happen in child components. So if you remember in the cryptocurrencies, in our app, I keep doing that. I keep meaning to do Control P over here. In our app, we talked about how we take state here, like the number of cryptocurrencies to pull and the high price, and we pass that down to components as properties so they can have access to it. We're going to see the same thing happening when we go to process events. So let's add this to the cryptocurrency API. Let's have the ability to block cryptocurrencies. Let's say as we're looking at this, the user wants to be able to eliminate Bitcoin from this list. Like I don't want to see Bitcoin. It's not a cryptocurrency I'm interested in. So whatever we're doing, just keep Bitcoin out of the list. So that would mean here down in the cryptocurrency element, what we want is, we want some kind of button here to ignore this cryptocurrency. Let's put it before the name. Right? We wanted to ignore button. And when we ignore this cryptocurrency, we want this to tell the app, don't show this cryptocurrency in the list. Right? So now every one of these cells has a button we can press, right, and something should happen. But what we want to have happen is way up here in the cryptocurrencies in my parent, I want to maintain a list of ignored coins. Up here is where I want the list of ignored coins to be. So let's say ignored coin starts out to be the ID of 1 and the ID of 52. We're going to keep the IDs of the coins here. Right? So ignored coins in the cryptocurrencies is going to be all of the coins we're ignoring. And then what we'll do down here is when we go through this map, we'll do a little bit of logic. Now we need, what are we missing here? A syntax error. We are missing now, we've got this parentheses that goes there, we've got this that goes here. We've got one too many of those. So now if we have a list of ignored currencies, ignored coins here, what we'll say here is if this state ignored coins includes the current currency's ID, we'll return nothing. So what we should see is Bitcoin go away. As we go through all of the coins, we're saying if this state's ignored coins includes the ID of the currency we're working on, don't give anything back to React. Otherwise, make a currency for it. So as I manipulate this list, let's take Bitcoin out of the list. Bitcoin comes back. Right? So this state here is maintaining the list of ignored coins. And the logic is up here for whether or not we're going to display that coin. But down here is the button. The button is in the child component, right? Because cryptocurrencies is the parent, and it's building cryptocurrencies, multiple cryptocurrency components, but it's the cryptocurrency component that has the button. So we have a challenge now. What we want is there to be some on click here. Right? Some, let's call it handle ignore. Right, we want some method here that gets called when that button is clicked. Right? When we click on ignore Bitcoin, let's go to the console. Right? Hey, we're ignoring the currency, right? But I can't do this .set state here. I can't set state ignored coins because that's not my state. Right? Every component has its own state. The state that I want to manipulate is up in my parent. Right? I want it, when I click this button and this handle ignore happens for this currency, I want to somehow tell the cryptocurrency's parent, please add my ID to this list. Right? Every component has its own state. What if I had a function up here called add currency ID to ignored coins? And it took the currency ID and it added so it got the ignored coins and it pushed that currency ID onto the ignored coins, and called setState, and set my ignored coins to the new ignored. Let's call this new ignored coins. That's better. New ignored coins. And set the ignored coins equal to the new ignored coins. Right? So I have this method that I could call that would remember that I want to have this coin ignored. But it's up here in my parent. Right? I can't call it from cryptocurrency because it's in a different class. Right? It's in a whole different component. But I can pass things down to my component. I can pass this method to my child component as a property. So now what the component is going to receive is the ID, the name, the symbol, the price, its own ID, the high price, and a function. The function to call when that component wants to add itself to the ignored coins. So up here in cryptocurrencies is where the state is. Up here in cryptocurrencies is where the method to add a coin to the state is. It's going to pass down to the cryptocurrency a function to call when we want to ignore a coin. So now in my cryptocurrency, let's get the currency ID to ignore. It's going to be what? Well, it's going to be this.props.id. And let's have this log what the currency ID to ignore will be. Right? So as I click on these different ignore buttons, what I should get is ignoring coin 1, ignoring coin 2, 131, 512, etc. Right? That's the ID of the coin to ignore. But what I want to call is I want to call add currency ID to ignore coins. Well, I can get that function by calling this.props. Add currency ID to ignored coins. Did I spell that right? Because that's just a property now of my component, and I can just call that function. So this function is not a function that I've defined in my component. It's a function that was passed to me. It was given to me by my parent. Oops. Oh, I have a typo. It's not pushed. It's not pushed. It's push. So hopefully now, when I click on one of these buttons, they go away. Let's reload this. So this is a child component affecting the state of a parent. The way we do that in React is we create a function in the parent that deals with that state, and we pass that method down to the children as properties. So that the child can then call that property function and pass it any information that it needs. Right? If you think about our Minesweeper, what's one of the things that when you click on a cell, might it tell the board?
If it has a bomb in it or
Well, the cell doesn't necessarily know
not?
where it is. Right? When I click on a cell in the board, I might need to tell the board, hey board, something was clicked, and where it was clicked. Because the board is going to maintain the state of all the cells. Right? The cell is going to have to tell its parent, I was clicked, right? I was flagged, or I was checked, and where I live. Right? It's cell number 1, or it's cell row 5, column 3. right? Just like here, we're telling the parent which cryptocurrency ID was ignored.
And you can just continue this ad infinitum, like, parent to grandchild.
Mm-hmm. Yep.
Just keep on
Yep, the
repeating.
parent could pass the function to the child, and the child can pass it to its child, and the child could pass it to its child, all the way down the hierarchy of components. Yep, and then when that's called, it calls all the way back up to wherever it came from.
Okay.
This is kind of the idea in React. We say data flows down, events flow up. Right? We take the data, the cryptocurrencies from the top, and the data flows down. One of the things that is data is functions, and those events flow back up. So it's almost like a big circle, right? Data flows down, and an event happens, it comes back up, it changes the data, and the data flows back down again. So it's just a big circle, right? One of the nice things is it makes it very simple eventually to reason about where our data is coming from, right? Your data for cryptocurrencies always lives up here, right? And if the cryptocurrency wants to manipulate something, it's not reaching across boundaries and manipulating information. It's just saying, hey, parent who told me that there's a function called add currency ID to ignored coins, I need you to do that work right now. You gave me this function that says you would do this. I want you to do it right now. And by the way, this is the currency I want you to ignore. Right? And that's what this function does. All it's doing is modifying its state. What happens when we modify state? We repaint everything. Right? So that's why when we click ignore Bitcoin, we're adding Bitcoin's ID to this list of ignored coins. Everything repaints. And because we told it if the ignored coins includes that currency ID, which it now does, don't put a currency, just return nothing. And away these currencies go. Right? So when you have child components that need to change state above themselves, you're going to be passing functions down to deal with that. Right? So the two parts of this was the Axios library, and we're going to see how that's going to be useful in a minute. And this idea of wherever your state is, where you're maintaining state, if you need to manipulate it from child components, you're going to define a function that does that work, pass that function down, call the function from the child. That's probably beyond understanding props and state. This idea of passing functions down so they can be called back is probably the next hardest thing that we struggle with in React. So that's why this Minesweeper is a good practice, because we're going to have to do that. Let's talk about the Minesweeper API, and then let's kind of mess around with it for a minute. So let's bring up the Minesweeper API and take a look at it. Did anybody get a chance to kind of read over that API page? Cool. Let's talk about what it says and how it's formatted and what the different things mean. So it says here's the documentation. So let's bring up this API. Okay, so it says this is a description of the Minesweeper clone API. So the way this is going to work is it's going to talk about this idea of resources. We're going to talk a lot more about resources when we get to the back end. Just recognize that resource is going to be, for now, you can think of it as two things: the type of request we're going to do and the URL that we're requesting it from. So you all have been web users for a long time, and you've typed in URLs into a browser, right? Google.com, Yahoo.com, whatever. When you type a request into your browser and press enter, you are sending what's known as a GET request to that URL, right? Google wakes up and gets a GET request. It's asking, hey, I would like to get www.google.com. Right? When you fill out a form and submit a form, you are doing a POST request. You are sending information to the server. There are many other types of requests, but the two that your browser can do natively are gets and posts. Gets are always what we get from the URL. There's no way to do a post from a URL, typing one in. And posts only come from forms. Right? A form is going to post. Forms can also get, but typically they post. We use post when we're sending data to a server. The idea with a GET request is it should be what we call idempotent. Idempotent. Idempotent, right, says that when we make a request, we don't change the thing that we're requesting. That we can ask for that over and over again without affecting the thing that we're asking for. Post requests are not idempotent. They may, probably do, change the thing that we're talking about. So here's the analogy I like to use. A GET request is like asking for the balance of your bank account. If you ask how much money is in my bank, and it says there's $100, if you ask again, there's still $100. And if you ask again, there's still $100, right? If you make a deposit as a post, and you deposit $20, right, that has changed the amount of money in your bank account. If you post 20, and you post 20, and you post 20, you now have $160 in your bank account. But getting the balance from your bank account will never change what's there. Now the balance may change, right? If somebody else is putting money in your account and you're asking for your bank balance, right? You get 100, you get 100, you get 100, somebody puts 20 in, you get 120. The idempotency does not mean that value is always the same. It's saying that that request did not change the value. Somebody else may have changed it, but you did not change it. Right? You should be able to make that request without any issue. Right? So one of the things I like to talk about here is kind of in the early days of the web when internet connections were really slow. One of the things that some browsers would do is while you were reading a page, they would try and figure out what links you might follow, and they would prefetch those links. So you're reading a page, right, and it's got a couple links on it, and it may try and figure out which links you're going to go to because humans are really slow at reading, but your internet connection was slow. So in the background, they would go prefetch those links, so when you eventually got around to clicking on them, they would appear almost instantly. Right? But it shouldn't fill out any forms, right? Because those forms might change things. This is why in coding, we always want to make sure that our links that change things are always gets and are always idempotent, right? If you have a link in your page and that link does something, it should not just be a GET request, right? Because the browser should be free to fetch anything, anytime it wants. And if that GET request changes data, right, some browser may decide to prefetch some data and change something. So we always try and be careful that GET requests should not change anything on the server. So if you look at our Minesweeper API, on the left-hand side, you'll see that we're doing some gets, but we're also doing some posts. So if you just looked at this list of API, you would see there's a post, a get, a post, and a post. We should know that post requests are going to change something. GET requests should not change anything. So even when you start looking at an API, you can start seeing which requests are going to change something and which requests are not. Let's take a look at the very first resource that we have is post. It's a /games. So /games is the URL we're going to access. It goes on the end of this URL. So this is the base URL. So all of our URLs are going to start with HTTPS Minesweeper API Heroku app.com. And then these things are going to be tacked onto the end, /games. If we post a request to /games, this API is telling us that this will create a new game. So if you figured out how to in your browser, we can't do it with our URL bar because we can only do gets with this. But if we were able to post to /games, we will tell the Minesweeper API we're about to play a new game. The parameters that it takes is a number which tells us easy, intermediate, or expert. If we send it a 0 for the number, we'll get an easy game. If we send it a 1, we'll get an intermediate game. And if we send it a 2, we'll get an expert game. And the response says it should be response code 201. So in addition to the data that comes back from an API, there's also a response code that tells you what kind of thing happened. This is my favorite site for understanding what HTTP status codes are. Status cats. Right? And everything that's in the 200 series is responding to things were okay. So if your website responds with a 200, right, everything was okay. Everything in the 200 series is some form of okay. Let's see what 201 is. Right? It's the cat walking across the concrete, created a mess. Our Minesweeper responds with a 201. So every response code in the 200 series says everything was okay with some flavor. Right? A plain 200 is everything was okay. I have no more information about how it was okay. But a 201 says everything was okay and I created something. Right? If we go through the rest of these, you'll see that 202 means everything was accepted. 203, oops, sorry. I'm going through these in order, and there's not a 203. A 204 means that there was no content. Right? I did what you wanted me to do, but there was no content here. Right? So depending on how something was okay, different APIs will return different status codes. Sometimes it's not enough just to look at the data that comes back from an API, but you also need to look at the status code because information will be encoded in that status code. Right? So 200 means everything is okay. Everything in the 300 series means go somewhere else. Right? A 302 is a redirect, go somewhere else. Right? You asked me for something, but that doesn't live here anymore. Where it lives is now over there, right? Like forwarding your mail. You asked for this URL, I'm telling you the URL is somewhere else. I think we all know the 404, right? 404 not found. Everything in the 400 series is you made a mistake. Everything in the 400 is like, hey, the user did something wrong, right? You asked for a URL that doesn't exist. You sent me data that was bad, right? 404 in the cool here terms is like you effed up, right? 408, right? Your request timed out. Like you were sending me data and you went away, like there's nothing more for me to do. All the response codes in the 500 series is I screwed up, the server, right? If you've ever been to a server that's down, you might get a 500 internal server error. So all these codes mean something, and you'll see that our API adheres to those codes. When we create a new game, we get back a 201. Something was created. If we click show here, we get to see what the data is. So what we should get back is a content type header that says what we're sending back is JSON. So we're going to be sending JSON. It's going to be giving us back JSON. And the body is what's going to come back in our Axios data. When we get that Axios data element, what we're going to get back is something that looks like this. We're going to get back a JSON object that has an ID of the number of the game we're playing. So every one of these games is uniquely identified by a number. Game number 1, game number 2, game number 3, and so forth. Then there's going to be a board key, which is an what? An array of arrays. It's an array where every element in that array is yet another array. How many elements are in this array? 8. Why are there 8 elements in this array?
Piece of the table
because there's 8 elements. It's an 8x8 grid. So there better be 8 elements here, and I'm betting there are 8 of these. This is our board, right? It's a new game, so every element in this board is just a blank space. At the bottom, there's 2 more data elements, a state and the number of mines that are left on the board. Right? So it's telling us there are 10 mines on this board, and the state of this game is this is a brand new game. Right? If we post to this URL, we get back this board, we get back a state and the number of mines. This kind of looks like the state of our game. This is probably going to be part of the state, the React state we're going to use, this board, right? And this board kind of represent what we're going to display inside of each of those cells. Right? If you have an 8x8 HTML, right, a table or divs, the contents of each of these board elements should be what you show in your page, right? This is getting a new game. So if we can post to /games, and that creates a game, let's figure out how we retrieve an already created game. So you see now this is a get, because it's not changing anything about a game. It's just asking for, hey, what's the current board look like for this game? And you'll notice here, it's telling us this is where we would put the ID. So if we wanted the status of game 1, we would do a get to games 1. Since we can do gets in our browser, look at what game 1 looks like. What? There's that 500 server error. Maybe there isn't a games 1. Oh no. Let's come back to that. That's getting an error from the server. We'll come back to that, because I'm going to show you how to create a game, and then we'll get a real game ID. We're not guessing a game ID. So getting a game with ID tells us the values for the cells. If there's an empty space in our board array, that is an unrevealed cell. If we have an underscore, that is an empty revealed cell. Right? That's a cell that's been revealed, but there was nothing in it. An F is an unrevealed flag cell. A star is a cell that has a bomb in it, which will only be there after a game is won or lost. An @ symbol represents a flag cell with a bomb in it, or a 1 through 8 representing the number of neighboring cells that contain a mine. You only really need to know these things in case you want to format the contents of the cell in some fancy way. If you just want to put those values into your game, awesome. If you want to use these values perhaps to show a graphical bomb, right, or a graphical flag, you would use these values to determine which image to put inside of that cell. Here's a hint, you could also use emoji characters for that. Right? If you don't want to deal with images, you could just turn the star into the emoji that's a bomb, right? Because that's a valid character you can put in your program. Let's take a look at the parameters. Just the number, which is the unique ID for the game. The response is 200, everything's A-okay. Let's look at the response. Hey, it's application JSON again. And it's exactly the same response, the ID and the board. But in this case, notice they're giving us an example that there are some numbers in some of these cells, right? There's a 1, a 2, and a 1 and an F. And there's a 1, some underscores, a 2, and some blank spaces. So this is the game that's in progress, right? Someone's been clicking and doing stuff in this game, and the board has some contents in it. So here's our next resource. If we post to /games and the ID number in our game, check, we are telling the server that we are checking a cell on the board. Let's take a look at what this requires. Let me shrink this down a little bit. Right? We take the ID of the game. We take the row. Which row did we check, and which column? Right? We're telling it some particular row and some particular column was checked on the board, and notice that it's 0 based. So if we clicked in the upper left-hand corner, that would be row 0, column 0. If we checked the upper right corner, that would be row 0, column 7. Right? Row 0, column 7. So we need to know every cell needs to know which row and which column it's on. Right? Because when we tell the API, hey, I checked a square, it needs to be able to tell the API which row and which column was checked. Right? The responses are 200. And the board looks exactly the same. Every API request is going to return the same thing with this API. You're going to get the entire ID, the entire board. Look now, it says there are 9 mines left. Right? So this number of mines is going to continue to go down if you want to show the player how many mines there are left on the board. Well, here's flag. It works exactly the same way. Games ID flag, we give it the row and the column, except this time we're telling it, no, we're not checking that square. The user right-clicked, and we're flagging that square. And the response is, again, exactly the same. Right? It's the ID and the board. Let's take a look at using one of these. So this is my favorite app for using APIs. It's called Postman. You can get it if you search for Postman. There will be an app for Windows and there'll be an app for the Mac. I think it still also comes as a browser plugin. I highly recommend you get this app as you're working with APIs. So you go to Get Postman. Right. And from here you can download Postman for your platform. It will launch an app that looks like this. Let me close all of these that I had to open. And it's like a playground where we can use APIs and see their responses. Right? So this is a tool that maybe we would have used when we were using the weather API. But that API was so simple we could do all of that work in the browser. So let's play around with this and see if we can get it to do some work for us. We can try out this API. So back here in our documentation, we want to do a post to /games. So let's grab this URL. And let's put it in Postman here. But we know that we put /games on the end. But it's not going to be a GET request. Wow, look at all the different kinds of requests there were. Who knew there were so many? Get, post, put, patch, delete, copy, head, options, link, unlink, purge, lock, unlock, prop, find, and view. All right? Our browsers can only do 2, get and post. But there's all kinds of things that backends can use to say, oh, you're asking for this URL, but are you deleting something? Are you copying it? Are you locking or unlocking something? Some of these are used for particular types of requests, like prop find is used by WebDAV, which is a way of accessing hard drives over the internet, right? File systems over the internet. We're mostly going to be working with get and post. So the API says that if we post to that URL and we send this, we should get back a game. Hey, look down there. Here's our game. What's our game ID? Say it louder.
11,237.
Yeah, 11,237. That is the game that we just created. Hey, success. All right.
Good job.
Hey, woo!
Thank you, everybody.
Yeah, congrats.
Congratulations.
Right, so we are playing game 11237. If we send this again, we're now playing game 11238. But game 11237 is still available, right? Someone's still playing that game. So every time we post, the server said, I've created a new game, and here's your board. If we wanted to get a game, we would say get games 1, 1, 2, 3, 7. And we would get that game. Right. Let's see if there was a 1, 1, 2, 3, 6. There was, and look, someone was playing that game. So you see there are sometimes Fs and sometimes numbers and sometimes underscores. This is a game that's been being played, right? There's still 9 minds left and someone was playing this game. It's an abandoned game, but somebody was playing it, right? But our game is 1, 1, 2, 3, 7, and we can get it. So let's flag a square, or let's check a square instead. So if we're going to check a square, what do we want to send? Games ID check with a post. So let's post to our game /check. But we need to send some parameters. Params. We need to send some parameters. We're going to send them in the body. So what we're going to send is JSON. The system said we're going to be sending JSON. So our body is going to be composed of some parameters that is JSON. What were the things that we had to send? The ID of the game. What's our game ID? E7. Somebody say what row they want to check. I heard 2. And then let's check a column. Somebody give me a column to check. 4. So there we go. We're going to send it this data, an ID of 1, 1, 2, 3, 7, a row of 2, and a column of 4. If we send this, we got back our response. Let's see if I can I move this up? There we go. Look at that. The game board is different. If we send that request, we get back a new board. Now, it's revealed to us that there are a couple of unrevealed spaces and some numbers to show on the screen. If we were to take this and reformat it, let's grab that and just take a look at it in a file, right? If we were to format it more horizontally, a little hard to see because they didn't put quotes around the numbers. And you can see it kind of looks like a board. Right? We kind of step somewhere and we've got numbers kind of surrounding this open space on the board, right? The underscores are spaces we've stepped on that are cleared. And all these are the numbers that we would show on the user interface. So if we were to save this in our state, and if our board component could display all of those cells, once we post that we checked a square and we updated our state, our game should refresh the display of the board. Just like when we fetched the list of cryptocurrencies and we updated our list of coins, the list of coins updated. So this board variable that comes back from the API is probably what your app is going to track as its state. Right? You're probably going to have a board component, and that board component is going to have this board as its state, and its job is to render all of the cells. Each cell is going to have to know what to display and where it lives, because when you make the request, you need to send it these things. So let's talk about the Axios library, how we would send this. So if we were in Axios and we were doing a post instead of a get, it would look like this. Here's our cryptocurrencies. Right? A post would look like this. Axios post to some URL, and we would send it an object. Then we would get a response. Right, so this might be, the ID is our game ID, right? Not hard-coded like this. A row, a column. This here is doing the same thing that Postman was doing. We're asking Axios to send a post to this URL and send it this information. We're going to get back a response, and we're going to do something with it. So if I were making this Minesweeper game, I would be building my user interface first. Right? In my app, I would build out all of my user interface just like we did with cryptocurrencies. Get everything kind of styled the way you want. Make sure you've got a nice grid, right? Maybe do a little bit of styling. And then see if you can extract that, whatever you're doing, a bunch of divs or a table, out as a board component. Kind of like we pulled the table of cryptocurrencies into a cryptocurrencies component. Then see if you can pull each individual cell into its own component. And then rather than hard code it, see if you can drive it from state. Just like we cheated in the cryptocurrencies, you could grab one of these responses and copy that in as your static JSON, right? And then as you went and tweaked this file, you could see that your board updated. Then hook up the clicks, then hook it up to the API. So kind of the same way that we went through cryptocurrency, from static, big HTML into components, right? Then add properties to those components. So you can drive what should it have in its cell, right? Is it a space? Is it an underscore? Is it a 1? Is it an 8? Right? Those should come from properties like our ID, our name, our price came from properties. Right? Then maybe take one of these board examples, either from the API docs or from Postman, put that in a JSON file and have that drive dynamically the board. Then see if you can hook up the click handlers. When I click a cell, I need to tell the board a cell was clicked. The board needs to tell the API a cell was clicked. Whatever comes back from the API, update my state. When a cell was flagged, the cell needs to tell the board needs to tell the API. Whatever comes back from the API becomes my state. If you follow that flow, that's probably your best flow for implementing Minesweeper. Right? It's going to be similar to cryptocurrencies, but we're working with a very different set of data. And we have more behavior here than we had in cryptocurrencies, right? We've got checking and flagging. But if you go through in that form, I think you'll have a successful process. So I would say if you don't have Postman, get Postman. Start playing with the API in Postman. Get your HTML done. And then flow through the process. John, do you have a question?
I was just going to ask you to repeat yourself.
Yep. So I would start with create React app. And inside of my app, I would build my entire page. Right? Whatever HTML you're going to build for this, your headers, your footers, your board, right? I think it kind of gives you the hint that it suggests that maybe you do this as a table, right?
Yeah.
So Maybe you do this as rows and cells, right? Probably easiest, but you don't have to, right? If you want to use Flexbox or something, more power to you. So somewhere you're probably going to have a table, right? Build all that and style it to some extent, right? So your cells should kind of look like cells. Your header should have a header, right? Whatever you're going to have for your fancy graphics. Spend some time doing that. Not too much time, right? That may be what I would spend the rest of the afternoon on, something like that. Then I would start extracting components. So whatever HTML elements represent your board, it's probably the table, right? I would extract that out as my board, right? So see if you can pull your table out of your app and put it in a board component, and then get rid of your table in your app and render the board. Then, instead of your board being a fixed 8x8 table, see if you can pull that cell out, probably the TD, and pull that out into a cell, right? Maybe when you made your static version, maybe you filled in some numbers, right? Maybe you made some of the cells, ones, twos, threes, eights, maybe some of them were underscores, right? Just like we hard-coded the Bitcoin price and the Litecoin price and the symbols, right? Maybe you've hard-coded certain cells to be certain things. Make those driven by props that you supply from the board. Okay. Then grab one of these boards from the API or from the sample, like we grabbed the API data from the cryptocurrency API, right? And we made it dynamic. We used map to take that that data and turn it into components, right? And then as you tweak that JSON file, you should see your user interface update, right? If you go into a particular cell in the JSON file and make it a 4, that cell should now be a 4 in the interface, right? And then see if you can hook up the clicking to see that the things are being clicked. At some point, you'll need a button in your app that says make a new game. What is that make new game gonna do? Post to /games and update the state with this. Then when you're clicking on cells in your game, right, they're gonna do one of these things. They're either going to check a square with a post, or they're going to flag a square with a post. And what does it need? It needs the ID of the game, and it needs the row and the column of the cell that was either clicked on or right-clicked on. So for the rest of the day, what I would suggest you work on is getting a rough outline of your page working in your app, and then see if you can start extracting that into components. Get that working today. That's a good target for today. Tomorrow, or today, depending on kind of how far you get, see if you can start driving those components with properties like we did in cryptocurrency, right? Then take one of these examples out as data, see if you can use map to generate it automatically. Then finally hook it up to the live API. Trust me, this one takes all weekend. Right? We're integrating a lot of things now. Right? Building the HTML and CSS, putting it in the app, looking for components to extract, working with data, and now events. Today, work on getting your app to render. Right? Get something that ends up looking, I should see why why does my Minesweeper does my Minesweeper not work? Oop, that's not what it was. I don't remember what it was. Right? I'll send you a couple examples of what students' Minesweepers look like, or I'll get mine working. I will also drop into Slack a couple examples of how to make requests with Axios. Right? So you can have that as some examples. But if you want to play around with the API, the best way is with Postman. So get Postman downloaded and installed. It's on the Mac, it's on the PC. It's probably the single best tool for playing around with APIs. Right? And just go back and watch the portion of the video where I used it and kind of play around with it yourself. You'll get different game IDs. You can click around on different rows and columns. All right, what if we click on row 6, column 4, looking to see if nope, we're still playing. All right. Let's click in the upper left-hand corner. All right. You can play the whole game this way just by sending the API requests on where you're clicking or where you're flagging. Let's flag position 1-1. Look, there's a flag in the second column, second row. Second column, second row. There's an F there because I flagged that position. Yep, makes sense. Best way is break it down. Start at the top, work your way down. You can flow kind of how cryptocurrencies went, but the data is going to be different style of data, but the ideas are still the same. Questions?
I think generally a good method is like following, I mean, it sounds like that's what you're saying, is like following data flow, like where it comes from to the event, and then like what the user does, and then follow that course of action.
Yeah. You generally want to start with the page as laid out as you can, breaking those down into components, then figuring out how the data feeds that. Right? It's kind of what we did with cryptocurrencies. Right? We started with the page. I just made a static cryptocurrency site in my app component. With no clicking, no data fetching, but all of the HTML was there. Right? At that point, if I told you this was a cryptocurrency site, but I didn't let you touch the keyboard or the mouse, you'd believe me. Like, wow, look, there's cryptocurrencies there. Right? But it was all vaporware. Right? Nothing was dynamic. I wouldn't let you touch the keyboard or the mouse because you would figure out my game was up. Right? I didn't actually make a cryptocurrency site. And I started breaking it down into components, but everything was still static. Same idea here, right? Make a fake game, right? Your 8x8 board that you make for your game should have some bombs on it, or have some flags and some numbers and some empty squares, right? You should be using these characters, right? Should have some of these in it. Empty spaces, underscores, Fs, stars, ats, and 1 through 8s. Start breaking that down like we broke down the cryptocurrency. Right. At some point, make the cell take props of what it has and where it is. It's row and column. Right? Then, if you steal one of these boards and put it in a JSON file like we stole the cryptocurrency data, and you have those cells generated dynamically, right, then they're not hard-coded anymore. Then when you hook up your game new and you update your state, you pass those states down as properties, like we pass down the ID, the name, and price of the currency. Now your board is generated dynamically. Then the hardest thing out of all this is hooking up the flagging and the checking. That will be the hardest thing out of this assignment. Right? And see how far off I push that? It's like the last thing that I end up doing. I always want the hardest thing to do to be the last thing that I have to do. I don't want it to be the first thing. I want to get progress done. Right? The very last thing I would do on this assignment is have the flagging and the checking done. Right? Then when you go to adventure mode, if you go to adventure mode, you can have it do a intermediate or expert board, and you'll see that those are different sizes. Right? So now you got to deal with not an 8x8 board, but a dynamically sized board. If you planned well at the part you were doing the dynamic part, that will be easy. Right? At the point that you turn the JSON data into components, if you did it well, that part will be super easy. Right? And that's the last part that I would do. Any other questions? Start working on, how many people already started working on laying out an app with some cells? Cool. That's what I would do for the rest of the day. Get that going, right? Fill them in with some fake data. Start breaking it down like we broke down the cryptocurrencies. This is another app where Cohort 11 did a good job of like getting together and working from the same spot over the weekend to answer each other's questions. Might not be a bad idea for this one too, right? If you like want to organically be like, hey, we're all going to meet at my place and work on this, or we're going to meet on campus on Saturday at 11 and work, right? That's a good thing, right? Don't copy other people's code, but ask questions, right? If you copy code, make sure you understand how it works, right? You can explain to yourself how it works. Like, yeah, cool. Like, I see how that works. I understand it. Maybe I didn't come up with it, but I understand it. If you can think you can explain to me how it works, put it in your app. Anything else? Anything someone wants me to go over again? That's what's on the video. Cool. So you're going to need the part that we did, part 1 and part 2 today of the cryptocurrency, and the part that we did towards the end of like, how do we handle clicking on that ignore button? The idea of passing functions down that get called back. That's how you're going to do the check and the flagging.